In this lesson, we're going to look at factorising monic quadratics. So to start off with, I've got a quick little activity for you. We've got this expression here, the xy plus 4x plus 3y plus 12. It doesn't have any common factors for every term. So when we looked at the previous example, we talked about how can we just sort of pull out a factor that's common to all of them. In this case, there isn't one, but we can still factorise it. So we use this method of grouping. What I want you to do is have a go at filling in this section below. So here I've got my xy original expression, and they've broken it sort of for you. They've said, all right, pull out x as a factor here. What's going to be left? So look at everything that's got x's. And if I take the x out, what am I left with? Now I've pulled out 3 as a factor, and I want you to look at the remaining things and go, all right, if I pull out 3, what am I left with? And then we're going to have something x plus 3 and something in brackets once we've sort of condensed this. So have a go at these examples here. And then this one is repeating the same thing, but the expressions are rearranged. So now we've pulled out a y and a 4 instead. And I want you to tell me if the two results are equal to each other. So the key ideas for this lesson is that we can factorize expressions using these common factors by taking out a common factor. And it doesn't have to be a factor that's common to all of them sometimes, which is what we just saw in this grouping concept. So previously we've seen that in an expression like 5x minus 20, we can pull out the minus 5 and we're just left with an x plus 4. In something like a quadratic, we've got 4x squared minus 8x. We can then condense that and go, we'll pull out an x and a 4. I can't pull out both because I've still got one here, but I'll pull out the 4x and I'm left with like, what times this gives me 4x squared? Must be x. 4x times what gives me minus 8x? It's got to be minus 2. The next thing we're actually going to look at a little bit later is using that difference of two squares, or difference of perfect squares. And we saw this last year in a more linear, more basic example, but we can now apply that to quadratics. So the difference of perfect squares is that if you have a squared minus b squared, that's equal to a plus b, a minus b. So an example is if we have x squared minus 5, this is not necessarily obvious because you're like, well, 5 is not a perfect square, but the square root of 5 times the square root of 5 equals 5. So suddenly we can say square root of 5 squared is now a perfect square. So what we've done is we've changed that to x plus square root 5 times x minus square root 5. We're using that difference of perfect squares rule there. And then the last approach we can use is what we just saw in the lesson starter, which is this grouping. So we pull out a factor that applies to some terms, and we pull out another factor that applies to other terms. So exactly what we saw above. With this example, we can pull out an x, and that applies to these examples here. I've got the x and the 5, and on this side I've pulled out a 2, which applies to the 2 and the 10. Then all I've done is I've condensed them. So the condensing process is a little bit different. You've got x times x plus 5 minus 2 times x plus 5. What do you notice? The whole point of this process is we end up with the same thing inside. This is now really the same as saying a lots of x minus b lots of x, right? Which we can just do that. That's a minus b lots of x. So because these things are the same, it's just x minus 2. And then this is the same factor. So it's the x plus 5, because that was the common factor really, and then the x minus 2 is what's left over. So that's the second step. That's the step up here and here that you maybe struggled with when you did that practice example, because it's a little bit new to use that step. So another little opening practice question for you. Look at these statements. Discuss what is wrong with these statements when you try to factorize this expression here. So this is something that you can discuss with your teams, chat with each other, see what you find out, but see what's wrong with these and then correct the statement that actually factorizes this properly. So the key ideas relating to this is that a monic quadratic, so a monic quadratic is something that has a coefficient of x squared being 1. Doesn't have a number in front of it. So a monic quadratic will always have a coefficient of 1. That's one of the key ideas here. And the next part is that when we have a monic quadratic, so an x squared plus bx plus c, where that value in front is 1, we can factorize it by finding the two numbers that multiply to give the constant term c and add to give the coefficient of x. So there's like a sum product rule here that's popping up. So we want to know what two numbers, so we want two numbers that add to give us, we'll call this b, because it's the coefficient, right? We normally call this a, b, c. And we also need those two numbers to multiply, multiply to give what? C. So for example, we are looking at an expression and we're going, all right, can I think of two numbers that add to give me whatever this C value is? Now can I think of two numbers that I can multiply and also give me that C value? So it's a little bit of problem solving. Let's look at a practice example. So here, we want to factorize x squared plus 8x plus 15. So if you remember the process, they add to give b. So add to give b, they times to give c. So before we even look at the solution, look at b, in our case, equals 8, c equals 15. So what two numbers add to give us 8 and multiply to give us 15? Maybe you go multiply first and you go, all right, well, I can think of 5 times 3, 15 times 1. Technically, I could do something really gross like 7.5 times 2, but that's probably not normally a common case. And then I needed to add to give me 8. So sweet, straight away, look at 5 times 3 gives me 15, but 5 plus 3 gives me 8. So 5 and 3 have to be my factors. And the last thing you want to check, which pops up in some of the more complex examples, like perhaps this one, is everything positive or do I need a negative? When we do this example, remember it adds to give us b. In this case, the numbers need to add to give us minus 5, not plus 5. So we go, what two numbers multiply to give us plus 6, but add to give us minus 5? That can be the little bit of a trap there. So this is just an example of a worked solution. Feel free to spend some time and just follow through these steps and look at how they've done it. But ultimately, as we said, the trick is that once you know that they're your factors, in this case, you can just pull them out and we can sort of jump a step to go, it's always going to be x plus one factor times x plus the other factor, which in this case was 5 and 3. And the order is not important in these cases. And then same thing here. They worked out that minus 2 and minus 3 are the two numbers because it makes sense. Minus 3 times minus 2 gives us plus 6. But minus 3 minus 2, add minus, so minus 3 plus negative 2 gives us minus 5. So we just chuck in x minus 3, x minus 2 in our brackets, and we've got our solution. Let's have a got some practice. So for these, let's just go with the first column, and then for these quadratic trinomials, let's go, I reckon we'll go first and last, because that sounds nice. We normally start off easier, build up to some harder stuff. For the last one, we're first taking out a common factor. So what we're doing here is we're adding a step. So here we've got 2, 14, 20. Hopefully you can see that 2 is going to be a common factor. Pull that out, then follow that process. Because remember, this works for monic quadratics. These are not monic. These have coefficients in front of them. The a is not equal to 1 in this case. So we need to make them monic. In these examples, let's do something a little bit quirky. And let's go across the bottom. So the bottom 6. As before, Solutions are on the right hand side if you want to check your work. Have a go at a few, then check your answers. In the next section, they're talking about an example of factorization to help build or create add and subtract algebraic functions. It's a bit of a complex process. Take a bit of time to have a look at this and try and work out what are they actually doing here. Then sort of mimic that process. So I want you to try and simplify the following expressions using this process. So we're just trying to create a common factor. Notice how in this expression we eventually created a factor that can cancel or condense. We want to do the same thing here. So let's go odds in this case. So we'll go A, C, E, G. So that will be our questions for this section. And that concludes the lesson for today.